Okay, today we're going to look at DEs in the form d2y dx squared equals a function of x. So we're talking about second order DEs. All that means is that we're going to actually have to anti-differentiate twice. So if we start off with d2y dx squared, second order, second derivative, is equal to cos 3x. That means that dy dx is the integral of cos 3x dx. So in other words, to go back from second derivative to first derivative, we anti-differentiate once. So dy dx will equal now the antiderivative of cos 3x. First of all, cos 3x becomes sine 3x, divide by the 3, so it's 1/3. Antiderivative of cos is positive sine, and we go plus c. That means that y is now the integral of 1/3 sine 3x plus c dx. So we're going to anti-differentiate all of this in terms of x. So that gives me y equals. Now the antiderivative of sine is negative cos. You need to divide by the k3, so that makes it 1/9. Plus, now the antiderivative of c is cx, because c is a constant, so the antiderivative of a constant, you just put an x next to it, and you get a new constant of integration, therefore d. So note, general case will have two constants of integration. Okay. Let's have a look now at finding the solution to d2y dx squared equals 1/x plus 1 all squared. Well, first of all, let's rewrite that in a form that we will be able to anti-differentiate. So, effectively, 1/x plus 1 all squared is the same as x plus 1 to the power of negative 2. So, the first derivative becomes the integral of x plus 1 to the negative 2 dx. So that equals, we're going to do backward chain rule here. So we add 1 to the power, which is negative 1, we divide by the new power, negative 1, and we divide by the derivative of the bracket, which in this case is 1, plus c. So dy dx is equal to negative 1 over x plus 1 plus c. So now y is the integral of that, the antiderivative of that, in terms of x. And so the antiderivative of negative 1 over x plus 1 is the negative natural log of x plus 1. The antiderivative of c is cx, and you get a new constant d. The solution to f double dash x, which is just the second derivative, equals cos squared x. And we've got a couple of pieces of information. We know that f dash x equals 0 when x is 0, and we know that when x is 0, y is negative 1/8. So, in order to do this, we need to actually change cos squared. So, f dash x, which is the antiderivative, is equal to the antiderivative of cos squared x dx. And of course, we're used to the fact by now that cos squared x is replaced with a half cos 2 times the angle plus 1 dx. Okay. So the antiderivative of cos is sine, and you divide by the further 2 from here, so we'll get 1/4 sine 2x. The antiderivative of 1 is x, but you've got a half out the front, so it's x on 2, and you get a new constant c. Now at this stage we can use the information up here, which is the derivative is 0 when x is 0. So 0 equals a quarter sine 0 plus c, which means c is 0. Now f of x is the integral of a quarter sine 2x plus x on 2 in terms of x. The antiderivative of sine is negative cos divide by the 2, so that gives me 1 on 8, plus the antiderivative of x on 2 becomes x squared over 4, and you have a new constant, d. Next bit of information is that y of 0 is negative 1 over 8. So if we substitute that in, we get negative an eighth equals negative over 8 cos 0 plus d. Okay, and of course that means that d is 0 because cos of 0 is 1, so d is negative 8 plus an eighth, so we get d is 0. And so the final solution is y equals negative 1 on 8 cos 2x plus x squared on 4. Now go and do those exercises. Monday we check everything.